right. Good morning, JCON. Is everyone awake? There was somebody sleeping in here when I first came to set up, but good morning. All right, very good. I like your dedication coming here to sleep to make sure that you don't miss the talk. That's like next level. It's great to see a lot of familiar faces. I've been standing out at the booth here for the past couple of days, so I think I might have talked to a good portion of you already. And yeah, I'm happy to see you here. Today we are going to have a very practical talk. As the name suggests, it's not going to be a whole lot of theory, but instead we're just going to take a look at some practical patterns that are pretty closely aligned, hopefully, to things that you might want to do in your day-to-day work. So less theory, more code. My name is Marcus. I currently work as the VP of AI research at a company called Vaadin. When I say AI research, it's not so much into trying to build new models or things, but we are a UI company, so I'm more looking at how does the prevalence of AI change the way that we interact with computers. What is that UI going to look like in a few years? So we're doing a lot of cool stuff there. Hopefully next year I can show some of that here, but today we're going to stick to stuff that we can already do today. As with all the talks here, there's a QR code that you can use to ask questions. So if you have anything that you want to ask me, you can type it in there before you forget it. And then towards the end, we can bring this back up and answer those questions. So if you see another question that is relevant to your interests, you can go ahead and upvote that, and it'll float towards the top and more likely get answered at the end. Good. All right, so I don't know about you, but at least based on the many discussions I've had at the booth, it seems like a lot of us here are in the business of building business applications. They're not necessarily the flashy, cool applications that are out on the app stores and the kids are playing. They're the apps that make the world go round. They make all the money. They're very important, but not necessarily as flashy. What I've seen in the 20 plus years that I've done this is that working with people who are building enterprise applications, that they're typically very data heavy. There's a lot of inefficient workflows. People are sitting in cubicles day out and day in doing very repetitive stuff. So I think the space is ripe for using a little bit of AI in kind of right places to make these workflows more smoother, less annoying, more efficient, less error prone. So really what I'm trying to do with today's talk is just give you some ideas where you might I could apply some AI there maybe to make this thing a little bit less annoying or time consuming or anything like that. So I think we have a chance of really kind of giving people a better user experience and being more productive. There's, of course, like with the current AI hype wave, also the kind of how would I say it? You might have managers who are very eager to put AI into all the things. I wouldn't necessarily kind of agree with using AI for all the things. So also being very critical about what actually does need AI, what could I just as well solve much more deterministically in Java is a good discussion to have with you and your boss. Maybe an if statement is enough to satisfy the AI criteria in many cases. Where I really want to focus is on all those things that 2 years ago, if somebody came to you and said like, hey, I need you to do this, you're like, okay, well, can I have a team of 10 people in 2 years and we'll try to make it happen? Where today you can be like, well, I'll probably have it done by lunch. So there are a lot of things that we can do today that just a few years ago would have seemed ludicrous if somebody asked us to do them. So let's take a look at some of those. I also want to show that AI interfaces can be more than that just kind of ubiquitous chat interface that we see in a lot of places. That is for sure a very kind of important and powerful way of interacting with an AI, but by no means is that the only way we can interact with an AI. I would say that in a lot of the apps that we're building, kind of sprinkling in AI behind a little button click or interaction with a UI element can be just as powerful and sometimes even more powerful when the user doesn't need to be an expert in prompt engineering to get the best possible result. The chat interface can sometimes be the most difficult to get right because it places so much burden on the end user to use it in the correct way. So if we can do a lot of that work ourselves and give the user something more predefined, that can really simplify things. Today we're going to work with two tools, Spring AI and Vaadin. We're going to use Spring AI as the library for calling LLMs for building out these workflows. Who here has not heard of Spring AI before? All right, great. There's a few of you. I was figuring, because I'm going the last day, that there's like a 90% chance that everyone has already had like 3 Spring AI intros by now. But that's great. I will kind of give you a gentle intro when we get to the code. The code itself is quite self-explanatory once we get there. The other library we're going to use is Vaadin, which is our UI library. So that allows us to build the UIs in Java. We're not going to really get super deep into either one of these. They're just tools for me to be able to show these patterns. So you could easily use, say, LangChain for J instead of Spring AI, do the exact same things. You could use another UI library of your choice just as well for Vaadin. They're not the important parts here. They're just something that enable us to learn this. The one little piece of theory I wanted to show you around Spring AI that's going to help us understand when we get a little bit further is that it allows us to build essentially chains of things that happen when we call an LLM. So between us sending a prompt or a user writing something in a chat, very often we want to do some things to that incoming prompt, maybe rewrite it for clarity, go and fetch some additional material that might be relevant for answering it, maybe check it for being kind of aligned with what our chatbot is designed to do, for instance, so that we're not answering questions about something entirely irrelevant. And then on the way back, maybe we want to process that response that we got and turn it into a Java object, or we want to do something. So Spring AI allows us to define a lot of steps that happen. And this is something that's common across a lot of the AI libraries, like even the name for LangChain kind of implies that there's a chain of things that you want to happen when you're calling the language model. So by no means kind of unique to this, but it's really kind of a powerful concept, very kind of analogous to having filters on HTTP requests or any kind of security frameworks where you have a very similar setup. I also wanted to include just a few, like 5 bullet points on effective prompting, since we are going to be speaking with an LLM. And speaking with an LLM, similar to speaking with a human, requires you to be very specific if you want the right results. So just make sure that you are clear as can be about what you want to achieve. Sometimes, or oftentimes, you need to provide the right context. So some questions will not have really a meaning unless you also specify within what context are you asking that question. How do you want the answer? Do you want the bullet point list of pros and cons? Do you want a JSON object? Do you want an HTML page? It's very important to kind of explicitly say what you want out of it. Sometimes it can really help if you're having trouble explaining in words what exactly it is that you want to do. Give a few examples, like if I give you this input, here's what I want for output. If I give you this input, give me that output. Once it locks onto that pattern, it does a great job, even if you change the input to be something entirely different. And really the last one here is the one that I want to highlight, is that very rarely, if ever, do you like come across the perfect prompt on the first time that you try it. And iterating and trying new ways of saying the same thing, looking at the output, changing it a little bit, and seeing how you can get the best possible output from there is really what's helpful. And that's perhaps one of the things that I meant when I said that the chat interface is really hard, because that places the burden on the user to be an expert at this, whereas if you place it behind a context menu click or a button or something, you as a developer can spend half a day finding that great prompt that translates that input given into exactly what you want, and then the user doesn't need to have all that insight into how to do that properly. So I think that's enough theory for us. Let's jump into the code and actually see some concrete ideas of what we're going to do. I'm going to share the GitHub link after this, so you don't need to try to take a lot of pictures or notes if you don't want to. You're, of course, more than welcome to do so if you want to. before we get too far, can somebody on the back row give me a thumbs up or down on font size? Okay, very good. Getting some thumbs up. So we are in a Maven project. This is a Spring Boot-based Maven project. We're using Spring AI 100 RC1 that came out almost 24 hours ago. So it's a little bit old, but I think should do here. Using Vaadin. And the kind of relevant things for us to see here are that we're using the starter for OpenAI specifically. We could change this to a different model if we wanted to use Anthropic or Gemini or whatever else we might want to do. The great thing about a library like Spring AI is that it offers an abstraction over the specific models that we're using, similar to like Spring Data offering an abstraction over whatever database you're using. So you can start with one model, switch to another. I'm using OpenAI here for two reasons. One, they have good models, and the other is that we're going to also look at using locally running models on my computer, and most of those also offer an OpenAI compatible API. So with the same dependency, we can use both local and commercial models. We're going to use Apache Tika for reading documents, so essentially allows us to read any kind of document known to humankind. And then we're using Postgres and pgvector for storing vector embeddings. We'll get back to that in a little bit, just when we get a bit further. But that's pretty much it. There's nothing especially surprising about this. If you haven't seen a Vaadin application before, this is how a view looks in Vaadin. So we have a bunch of UI components. If you take a component like a layout and you give it a route annotation, you say that, hey, I want this component to be mapped to the context root in this case, so I can see basic calling is here. And then I just define some components that I want, like I want to have a message input here. And when that message input gets called, then we're going to do something here. So the kind of very basics of calling an AI through Spring AI looks very similar to if you've used like the Spring REST client. You have a builder, then you create a client by calling builder.build. We're going to take a look at some additional steps here in between. But once you have the chat client, you can then start prompting it. So in our case, we have the submit listener. So whenever our message input gets triggered, we get the message, so whatever the user typed in, from the event value. Then we create two markdown messages. So LLMs tend to always want to return markdown, and we want to just display that markdown. So we first of all, we print our own message so that it shows up in the chat, and then we have an empty message for the response. We get the response by calling the chat client, and we say that we want to prompt it, give it our user message. Then we say that we want to call, so we send the call over to the LLM, and finally we collect the content, which in this case will be a string. And then we just set the response markdown. So let's take a look at how this works. So if I say hello, I hit send, it's going to first, again, show that message with our message, and then the AI response there. Now, there are a couple of things to note here immediately that may or may not have been kind of clear. But if we were to say, like, I saw there was somebody today on Blue Sky saying that they wanted Java haiku, so let's create one, a haiku about Java. Well, that was too fast. Write a song about Java in Cologne. Something that takes a little longer. So you see, now we're kind of blocking the UI for a very long time because that song generation happens to take quite a long time. And that may not be the best user experience because the user's not really sure what's happening. Like, sure, we can show a couple of dots, but if you've ever used ChatGPT or the like, you know that the kind of common solution to this problem is that we want to stream the response as it's coming in. So let's take a look at how easy that is to actually achieve here. So instead of calling the chat client with this call, what we're going to do is we're going to still prompt it. We're passing the same user message. Instead of call, we're going to say stream. So now we're streaming. And when we call content on this stream, what we get is a flux of strings. So essentially a stream of strings, every string being a token that's getting generated and sent our way. So with that, we can then say that we want to subscribe to it. And in our case, let's append that to our markdown as it's coming in, like this. So let's try again. Write me a song about Java in Cologne. And that gives us a much nicer user experience because now we're showing the user that something's happening. It's good to know that when you're using the streaming API, the total time of generation is often longer than if you just call the blocking API because there's a lot of overhead of sending each token one by one. But the kind of perceived experience is that it seems faster because you're getting an answer right away. So depending on what you're doing, if you're just processing docs in the background, use the blocking API. It doesn't matter. It doesn't kind of give you benefits to streaming. Good. All right, so this is kind of a somewhat working thing, but there's still a couple of things that we want to improve here. So first of all, if you've ever used an LLM through an API, you might have noticed that they are entirely stateless. So every call to them that you make is the start of an entirely new conversation. So if you don't give them that relevant context of what you're talking about, they're not going to know what that is. So if I say, my name is Marcus, and then I ask it, what's my name? I forgot. Then it will give us some unhelpful answer of it not knowing because in its world, we sent an entirely new message just saying, hey, what's my name? Without any context of what the heck I'm talking about. So it could not possibly know how to respond to that. So that's where those advisors start coming in that we were looking at. So what we can do is we can define advisors. One would be a message chat memory advisor. And that will help us store the history of chat messages going back and forth. For that, we need a chat memory, which Spring AI provides to us by injecting us. So if we don't specify anything else, we'll get an in-memory chat memory. That's perfectly fine for demoing stuff like this, but there are implementations that persist these chat memories into different data sources based on what you need. So we're going to create one like this, just saying that we want to have a basic one. We're not going to configure exactly how much memory we need and stuff, but what should happen now is that once this reloads and I say, hi, my name is Marcus, and then I ask, what's my name? It now remembers who I am because we added that advisor around. So what that does is like when we send the message, it captures our message, and when the message comes back, it will also capture the response and just build a history of messages that it passes along on each call. So that way, we're able to maintain that history and kind of have a more sensible chat. Another thing that you very often need to have in anything that faces the public or even internal is some sort of guardrail, something that keeps the discussion on topic. So we're going to use a very simple one that's built into Spring AI, but it's behind a interface, so you could implement your own that is specific to your needs. But we're going to add a new safeguard advisor, and this takes a list of words that are forbidden. And in our case, I think we can all agree on PHP being the one that should not be mentioned here. So let's see what happens. Yeah. So now we have a production-ready AI that knows what's up. Good. Anyway, so for instance, I have built one public-facing chatbot that kind of helps users interact with Vaadin documentation, and I've had it like initially online for a while, and I took it down at some point, and a user got back to me like, hey, why'd you take it down? I was like using that for all my like daily like ChatGPT purposes. I'm like, yeah, that's why I took it down. So what I ended up doing is I built a little advisor around that took that question and said, like, is it in any way related to web development with Vaadin, Java, and Spring? If not, just like say no. And if yes, then you're allowed to answer. So it's very kind of good to make sure that whatever people ask in these interfaces is actually appropriate. And the final thing I wanted to show here before we get to the kind of more interesting ones is defining a system message. So a system message will allow us to give the AI a persona. We can give it some instructions on how it should behave, who it is, and that way it can answer in a much more appropriate way. So let's actually take that away. And so if I were to just ask this right now, like how do I build a button without any, well, okay, let's remove that just in case. How do I build a button? So now that we're asking a question without specifying the context in which we're asking it, it's like, well, you could probably create it with HTML or CSS, or you might combine the two or do stuff. So it's giving us very vague roundabout answers depending on how it feels. Like sometimes it'll answer me in 4 different languages or anything. So by giving it a system prompt here, we can be more specific. So let's say you are a Vaadin expert, answer questions about Vaadin development, like that. So now we're giving it some context, like it understands who it is and how it should answer things. So of course this could, we'll take a look at some other examples, but this will now give it some context to what we're asking. So how do I create the button? So now, because it knows that it's a Vaadin expert and it should answer around Vaadin development, it's giving us immediately a right answer. So this way, the user doesn't need to provide that. So the user can just ask things with its kind of implied context, but still get a very relevant answer. Good. So this is obviously still the chat interface that I was talking about. It's super flexible, but also requires the user to kind of know all the right things to use them efficiently. So let's take a look at some more kind of pre-baked solutions, things that we might be able to just offer to our users as a service. So one common thing that AI is used for is analyzing documents. So you have lots and lots of documents. You have meeting minutes, you have chat transcriptions, whatever. One thing you could serve is just analyzing that. So in this case, we have 2 different ways of analyzing it. One would be to just summarize this sprint planning meeting that I missed. And in this case, it gives us a list of bullet points of things that happened, who said what. And yeah, I mean, it's still, I don't feel like reading that much, so just let me know what the action points were. And again, it will look at that and try to identify which are the kind of relevant things for me to kind of understand who is doing what based on that. So Priya is doing this, Alex is doing that, and this would be a super helpful way for me to just get up to speed on what's happening. So what you could see as a difference to the previous example with the chat API, as a user, I didn't have to write the prompt here to explain exactly what I wanted. I could just choose, like, do this action for me. And how I implemented this is essentially I have 2 different system messages now that I can choose between to give that context to the, or kind of instruction to the bot. We have a Vaadin upload. We're not going to look at the actual upload code. That's not very interesting. What is interesting is that we parse the file using that Apache Tika library. So we could have uploaded a PDF or a PowerPoint or whatever file we happen to have. And the actual analyzing happens here. So again, we have our chat client that we created. We prompt it. And depending on the mode, we use one of those 2 system messages. And then we pass in a user message, which is, here's the text to summarize. And then we ask for the content, and then we display that as markdown. So the benefit here, again, is that we have taken the work of creating that perfect prompt. These are not perfect, but like hypothetically, we could have, as developers, spent an hour just trying different inputs and outputs and see like what works, what doesn't work, how do we tweak it to be really helpful, and then expose that to the user as just a simple upload interface where they don't have to be the ones who understand how to prompt it in the right way to get the most useful output. All right, sort of similar. We're setting up a pizzeria, and we get a lot of feedback on our products. So much, in fact, that we don't have time to read it all. So we can maybe do a little sentiment analysis and just look at like who's angry at us, who's happy. And by analyzing the reviews, we can tag some of these as positive or negative. And we could also help our customer service reps by taking one of these and providing maybe a template for a response. So if we click respond here, it'll take the name of the person, it will take the review, and it will try to generate some sort of appropriate kind of response template. So again, the user didn't need to provide any prompts like, hey, here's a review, please write a helpful response to this. They're all just a button click away. Again, we as developers can provide the right prompts behind the scenes to do this. So if we take a look at what's happening here in the sentiment analysis, we have essentially two calls that we're making. One is for analyzing the sentiment. Here, essentially the prompt is very easy. We're saying analyze the sentiment. The interesting thing here is a feature of Spring AI that allows us to get the answer back in a specified format. Like we talked in the prompt engineering techniques, if you will, is be specific about what format you want. So in this case, instead of asking it to just provide us with Markdown, we're saying like, hey, I want a sentiment response, which is a record. So in this case, I said that I want a sentiment response where essentially I just have an allowed enum value. So that way, when I get that back, I can directly map that to my data model. I don't need to fiddle around with parsing JSON and trying to make that work. Like Spring AI is doing all of that work for me. Similar in the drafting response, again, we have a system message where we're telling it that it's a customer service rep. It should be friendly and respectful. It should be kind of concise and to the point. And what we're doing here is we're creating a more fancy user message, if you will. So instead of just passing a string here, we're using a lambda where we're saying that the text is this. We're using some template parameters here, where the name and review, and then we're setting the parameters to what we get from that review. So here we're also using templating to provide a kind of a pre-baked good prompt template, and then we can just pass in the values there to be able to get the answer there. So again, really what I'm highlighting here is that this allows us as developers to define and kind of iterate and build great prompts that the user can then just use at a click of a button, which is super convenient to the user. They get all the benefits and we do all the work. Cool. All right. So the next one I think is pretty cool. And this is definitely in the category of like if somebody told me 3 years ago I needed to do this, it would have been a much bigger problem than it is today. So hypothetically, if we were to run a user group, I know there are some jug leaders here. Who here is a jug leader or runs a jug? Okay, so there's 5 of us at least. So you might have at some point in the time had a sign-up sheet like this where you have everyone sign up and maybe provide some details and t-shirt sizes and stuff, and then you have this piece of paper somewhere and you're like, I don't feel like writing all of that. So let's take a look at how we can very simply solve this right now by just uploading it and having a good prompt and a library like Spring AI saying like, hey, we actually want to extract relevant information in a structured format from there and have it in a data grid where we can just use this for our use. So now we could easily, since we have it in a list of Java objects, we can do whatever we want with it. We can persist it, we can send emails to them, or whatever else we might want to do. So the way this looks And you're going to start to see a pattern here because these are, from the LLM standpoint, they're very similar things. So again, we have a chat client. We're prompting it. We're creating a user message with a text. So here we're just saying, read the attached sign-up sheet and extract the participants. Then we're passing a media part to it. So a multimodal model like ChatGPT or GPT-4.1 that I'm using here supports both text and image input. So in this case, we're adding text and image. We're getting the MIME type from the uploaded image, and then we just pass in the actual resource there. And again, we're reusing that same thing that we were doing previously. So we're saying that we want this in a specific format. We want a sign-up sheet, which is a record that has a list of participants where each participant record essentially maps to that. So by giving the structure that we want out and just letting the AI go at it is remarkably efficient. I've used this for receipts. I've used it for all kinds of things, and it just works. So the fact that we can not only use text as input is incredibly powerful, and I think and hope that as you're watching this, some ideas are starting to form in your head, like, oh, I could actually do that in my project. What was really kind of interesting and surprising to me, there was a person at our booth yesterday who was asking about this, and we're talking about local models, so I think I'll do a little side tour to that. So a common question I get from developers when I'm talking about this is like, oh, this is all nice and cool, but in our company, we're not allowed to send data to random data centers in the US, and that's not great, but can I still somehow use this? So one of the reasons I chose to use the Spring OpenAI dependency is that a lot of local models like Ollama, looks like this project, allows us to run LLMs on our own computers. What's great is that they expose an OpenAI compatible API, which means that we can use that same dependency to call our local computer by changing the base URL to our local host and then defining what the model is that we want to use. So in this case, I'm going to use Gemma from Google, and I'm going to go ahead and start this. What's cool is that Gemma is also a multimodal model, so it also knows how to deal with images. So hypothetically, we should be able to run that exact same image recognition task completely on my laptop without ever going to the internet. So let's see if that works. So in this case, we're now not sending anything outside this computer. We're just staying on my laptop. It'll probably take much longer because it's now actually running that on my computer. Also because I probably didn't load the model before times. It actually had to first load the model into my GPU and then run it. But we can see that it worked. And this is like mind-blowing to me. Like 2 years ago, the idea that I could run something this powerful on a laptop, not connected to a power source, it's just like crazy. Anyway, just wanted to show you that even if you are in a situation where you're not necessarily able to use some of the models, whether that's because you don't want to give them your credit card or your company policies, say you can't, using a tool like Ollama might allow you to use some models locally to play around with all of this. Anyway, since I haven't tried all the examples with that, we're going to go back to the OpenAI. I'm using, by the way, GPT-4.1 Nano for this, so super quick model for all these demos. Cool. So the next thing I want to talk about is how do we connect to our actual data? How do we interact with our system from an LLM? So it's kind of cool, of course, that we can upload things, but it would be sometimes really handy if we could give the LLM access to some parts of our system where it could pull things from our database or modify things or kind of do work for us. So in this case, I have a hypothetical product database here, and I should be able to kind of interact with it. So if we first take a look at how this is implemented, it'll give you a better idea of what you are looking at. So again, we are going to have a chat client here. And what I'm doing here, the only kind of really new thing that we haven't seen before is I'm defining a set of default tools. And these tools are provided by my product service. So I have a service class, and in my service class, I've added tool annotations to certain methods that I want to make available. So by adding this tool annotation or tool parameter annotation, I'm able to provide a description for the LLM. Like, this is a tool that you're allowed to use. Here's how it works. Here's what I'm expecting you to pass in. Here's what you're going to get back. And by doing this and passing them in as tools here, we're making them available to the LLM. So the way this works is that when we send our prompt to the LLM, along with that goes essentially a little bit of metadata saying like, hey, answer this. By the way, there are the following tools available to you should you need them. And in that case, the LLM might look at the prompt and say like, I can't answer this without first calling one of these tools. So then it'll send a message back to us saying like, okay, please run this tool with these parameters. We send the result back to the LLM. And at that point, it has our original prompt and the result of running that tool, and then it has all the data it needs to do it. So it's not directly running things on our computer, it's requesting us to run those things. But what that might look like then if this is sort of just like a visualization of our database, so we know what we have, and this is our interface. So you pull up ID, 5. Okay, so it found that product 5 is a 55-inch 4K Ultra TV, something. Change the name to Awesome TV. Okay, so I didn't actually remember to implement the logic for updating this, but let's refresh the browser and see, where's number 5? There it is, Awesome TV. So it went and updated us. Let's write me some add copy about product 5. So you can see that we're now interacting with things from our database. We can pull things from there. We can update them. Obviously, if you are doing this, you need to be more prudent about actually checking what the LLM is trying to do. So my suggestion here is just make sure that whatever you annotate as a tool have actual logic in Java checking that whatever it's trying to do is allowed for that user. It makes sense from your business standpoint. Like, have very strict rules. I noticed like earlier, like a year ago, for instance, when I was using some less advanced models, like just the fact that you show them that there is this tool, they would try to call it with whatever just to see what happens, and that's not usually a good thing. So you want to make sure, like any kind of outward-facing API, be very kind of careful about what you allow people to do. But that said, it is very powerful, giving that LLM that context, the ability to be more agentic. It can figure out on its own that, hey, if I need to write ad copy for this product, I first need to know what it is. So let me first go ahead and pull that out and use it. Good. Then the following thing I wanted to talk to you about is retrieval-augmented generation. So who here is unfamiliar with retrieval-augmented generation as a concept? Okay, so that's a third of you. So really, retrieval-augmented generation, I'm not going to go through the slides here because we're running a little bit short on time. But what it means is in the name, essentially. So we're retrieving content to augment the generation. So this means that when we're asking a question, we're going to try to find relevant sources to give to the LLM that's going to help it answer this question. So in our business context, that means that if somebody asks the LLM about something that it's not trained on, it's something that's specific to our business, what we might actually do is we might go and go through our business policy documents and just pull the right pieces of those into the LLM, essentially giving the LLM an open textbook question. So not only are we asking it the question, but we're also giving it the relevant documents for answering it. And by doing that, it's going to have a really easy time doing kind of answering. So if we, as an example here, I mentioned that I'm using a very new version of Spring AI, and it came with this retrieval augmentation advisor. So this is something that allows us to build a pipeline for answering RAG questions. So if I remove this for a bit, and let's just ask the base GPT model about this thing that just literally came into existence a few weeks ago that it's not been trained on. So let's see what is. So it's actually doing a pretty good job guessing, but it is, in this case, it's not related to our context, which is Spring AI. So what we would like to do in many cases is that we want to provide some documentation. So in this case, I extracted the official Spring AI documentation into a PDF, and let's go ahead and upload that here. So this now will act as a kind of source of information for it. It's not going to pull the entire document in, but it's going to find the right parts of that document to include. So if I now ask, what is retrieval-augmented advisor, it's going to say that it's an out-of-box RAG provider by Spring AI that helps with common workflows. So by providing more specific information, we're able to answer questions much more efficiently. So this essentially consists of two parts. One is how do we take that document and make it available in a format where we can easily find the relevant documentation. That is fairly straightforward with Spring AI. It looks something like this. So this one-liner split on 3 lines essentially is everything. We take our whatever document resource we have, we read it in essentially this just transforms it into one giant block of text. Then we take a splitter and we split that document into meaningful sections in one way or another. So if you have a semantic document like Markdown or something, you might be able to use kind of headings as a guideline for splitting things into meaningful sections. And once you do that, you take each section and you run it through what's called an embedding model, and that returns a vector value that kind of that encodes the meaning of that text. So once we have the vector value and the text, we can store them in a vector store. And like you remember, I showed you earlier, we're using PG vector, so Postgres with a vector store to store the vector value and the text value, which means that when we get to the actual RAG implementation up here, what we've defined is that we want to retrieve from that vector store anything that's semantically similar to this question that just got asked. So the way a vector search works is that it is looking for things that are similar in meaning. So when I'm asking for what is retrieval-augmented advisor, it will try to find things within our documentation that are similar in meaning to that. It will then add all of those found sections of the document into the prompt, essentially generating a longer prompt saying like, what is retrieval-augmented generator? Answer using these texts, and then that gives us the context. So at its simplest, it looks something like this. So again, we're building a chat client. We added our memory advisor. Then we have this retrieval-augmented advisor, which allows us to build a kind of a sub-pipeline, if you will. And in there, we say that we're going to pull from our vector store. In this case, the vector store is automatically configured because we have that PG vector dependency there. And then we're saying that once it's retrieved those, it should augment the query, so add to the query those documents. There are a lot of extra steps that you can add, and I'll kind of leave this commented out in the code where you can go in and see, but you can transform the query. A lot of times people won't ask things in the best possible way for us to be able to answer. So maybe you want to rewrite a unclear query into a more clear format. Maybe you want to maybe you want to find some content that's kind of related to the original query. So if somebody asked, for instance, what are the benefits of exercising, you might want to expand that to search actually for what are the benefits of exercise or cardio or strength training, and that way you get a wider array of content to pull from. Okay, so I'm going to stop here, and I'm going to share the link to the GitHub, and I'm going to be up here at the Vaadin booth, so if you have any questions around this code, you can always find there. Yeah, so let me just leave this up here for a brief second, and then we'll do 1 or 2 questions. Okay, all right, so I have a couple of questions here while we're taking pictures. So how do you reason about AI spend and right-sizing the models for each task? Good question. Obviously, models cost money depending on both how much tokens you're using and how good the model is. I haven't found a better answer to this than just actual engineering, trying out, seeing what works, what doesn't work, and trying to find like a sweet spot between a model that's cheap and fast, but still does the job that I want it to do. Sometimes you can notice that a smaller model can do a task well if you just give it more context. So sometimes even a easier, like smaller model will do fine if you just give it more context than a bigger model. All right, what about sensitive data processed by Spring AI? Will it be exposed? Are there mechanisms to protect them besides locally running Ollama? There's nothing in Spring AI specifically, but if you remember this pipeline of advisors, you could essentially have one advisor that pulls sensitive data out, IDs and stuff, and replaces them with some sort of tokens that then on the way back you kind of put back into your kind of actual tokens. So that is one way we could do. I think we are pretty much at time. One more, okay. Okay, let's see here. Okay, so then we'll do the last one here that I didn't answer. So any advice on how to influence building AI in Java at business level where Python is currently favored? I think if you, as a company, are a Java company, you're not doing Python otherwise. I don't think like this is necessarily the place that where you want to start using Python just for the heck of it. There are really good tools for kind of interacting with AI in Java, especially this type of work where we're actually building functionality that uses AI. It's a little bit different if you were to like train models or actually like build new AI things, but if you're actually the consumer of AI, I think it's much easier to just stick to the language that you already know, that already kind of fits into your existing ecosystem, and use that. All right, so sorry for running a little bit late. I will be at the Vaadin booth all day, so if you have any questions, I'm happy to dive into code-specific questions. You can reach me at Marcus Hellberg on the places, and thank you for coming.